Duvid here. We are live at the Injection Molding and Design Expo from concept to delivery here in Metro Detroit. The exciting field of injection molding, one of the most prominent methods of engineering and design. Last week in the same room was actually significantly bigger, twice, 2 or 3 times as big. The Society of Manufacturing Engineers had the conference almost specifically dedicated to additive manufacturing, 3D printing, and I ended up writing an essay on it.
Injection molding?
Oh yeah, I come back and just recording a little. Thanks. Yeah, additive manufacturing was much more exciting, more people, but this is actually still the dominant method of injection molding, which I actually wrote in my essay. I'll link it in this video description later of the history of additive manufacturing. So from general engineering manufacture, there's subtractive methods and there's molding methods. Subtractive methods would be milling, CNC, where you take a larger object and you mill it down to the shape that you want. And then more common than milling, the most common method in engineering used is injection molding. And that means you get a mold, which is a reverse engineering. So if you have your object, then you'd have a 3-dimensional carving that has everything except the shape of your object. And then you would inject a liquid, usually heated, into the mold and let it dry, and then you have your object. And usually there's multiple methods. Usually it's done with 2 pieces, top and bottom, that come together. There would be a small entrance that would allow the liquid melted part to be injected, and that would be heated. And then as that dries, then the top and bottom part would be taken apart, and you would have your object. And like 3D printing, you might have a tiny bit of finishing. For example, where the mold is injected, that little piece might have to be sanded or cut down. And actually, injection molding dates back to the beginning of the Bronze Age, where historically, like a smith, an ironsmith, a bronzesmith, going back to swords or earliest tools, they didn't necessarily have a 3-dimensional. A lot of times they just had, if you see videos or look into the original smithing, where they would just have concrete, a stone that had been chiseled to the shape of the object, and then they would melt the metal and pour it inside molten hot metal, which could be over 1,000 degrees Celsius, and then they would pour it into the stone slabs that had chiseled out the shape. And then after it melted, they would remove it, which sometimes would require a little bit of work to have it removed, but they would remove the object, and there you would go. So that the original tools, swords, military equipment, shields, construction equipment, hammers, farming equipment, all of that was done as a precursor technology to injection molding. So I didn't research the history. I have to look more into it, like exactly when the first injection molding, and probably a few hundred years ago, in terms of having a 3-dimensional mold that would have a top and a bottom, and that would be put together. And it was probably also originally for metal smithing, and like the commonality of the name Smith. Many people were trained as smiths, and then you would have probably just had two chiseled rocks, concrete, 1 foot on top of each other, and you would have had a big vat of molten iron or some sort of metal, copper, the lead pipes, the original lead pipes going back to Roman times. So they probably had some form of injection molding in ancient Rome, in order to make the lead pipes. And maybe they had a top and down structure. So, just a little historical backdrop on the history of injection molding and why injection molding is actually the most common form of manufacturing. Historically, it goes back. And there's also die casting for automobile, like subtractive manufacture, where you have a sheet of metal that would be milled or die casted, stamped out, and that's what it's called, subtractive engineering, because you would have a sheet of metal and it would be folded, stamped, clipped in order to get the desired product. And it's subtractive because there's a lot of waste, and a lot of the original product is actually subtracted. And that's why 3D printing, additive manufacturing is such a hot technology. Injection molding is not the same thing as additive manufacturing, but it could be considered closer to it than old school milling or die stamping, because it's not done layer by layer. It's done all at once. You have something that is usually melted, put in a liquefied form, and then injected. And then it's melted, and then it's allowed to dry, and the mold is taken apart, and the piece is released and things. So, and I'm going to walk around and gather some reading material. You can see you got robotics and automation. I think next week is the automation conference. But additive manufacturer could do hundreds of thousands of pieces a day. They could literally do, I'd have to see the specification, maybe even quicker than a second, a few seconds. Even metal, so even if it was molten metal at over 1,000 degrees, if it was sand casting, you have to see the site material science, because the key is the mold. There's a few keys to the mold. The mold has to be able to resist the heat of the liquid. So if you have a sand cast where the rock mold isn't going to melt up to like 1,500 degrees Celsius, and you have molten metal at 1,300 degrees Celsius, you could do mold injection. Plastic melts much lower temperatures. A lot of plastics melt at a lower temperature than even water boils. Although water is already liquid, so we're talking about turning a solid into liquid, so it'd be like ice turning into water. But a lot of plastic will melt at 3D printers. A lot of 3D printers operate at about 60 degrees Celsius, which is something. But there's various materials that have the specification. I'm going to go around collecting reading material. COVID-19. See not too many people in masks here, but I got my mask on, but I'm a little more cautious than the average person. But so I probably won't do any interviews or anything like that. But I'll try to gather some reading material. Let me walk around and see if you have interesting equipment. But you could have an automatized process. John, thanks for tuning in. Thanks for the first like. So if you had a automatized process where you have one single mold, you would have a separate part that would have the liquid being melted, and then it would be injected into the mold, and then the mold would be open, and the piece would be extracted. So here is, I guess, a full molding process. and you can see the conveyor belt and the mold. So you can see pretty quickly, maybe a few seconds, a simple plastic mold where they have, simple mold, an injection of a plastic, the release of the mold, and the extraction of the part. So here you see a simple molding press machine. I mean, not so simple. It's probably even more expensive than a 3D printer. It's like relatively a mold. Even though 3D printers cost hundreds of thousands of dollars for good industrial ones, this machine for injection molding is probably significantly more expensive than a 3D printer. It would be reconfigurable, so the heat level, so possibly a mold machine like this could be used for multiple things, and you just have to set the temperature, change the supply of the plastic or the material that's being fed into it, and the mold. So with a small piece like that, the mold is pretty small. It's only like a few inch product, and most widgets or even car materials are pretty small. They're only even car parts. They're not going to be much bigger than a foot. And if you're talking plastics, even for an automobile that might be a few feet wide, you could probably have a simple machine like this that would mold the part. Because all it does is melts the material, shoots it into the mold, and then opens the mold, releases the part, and puts it on a conveyor belt and collects the part. Also the material. So I mentioned the melting temperature. So if you have a material that is resistant to heat higher than the material that's the key of the mold, and then there'll also be like a stick factor, whether how easy it is to actually release the product from the mold. And so that one, it probably just pops right out. Like in the old days where you had like metalsmiths, they might have even had to grind and even to have a regular mold to get the sword, like the sword in the stone. That once the sword was put in the stone and then melt and then allow it to cool, how did they get the sword out of the stone? And so they had material to it, but that's where you have the classical sword in the stone legends. And conceivably, if it's done right, the sword pops right out, and even you wouldn't have to make a new mold or fool around with the mold each time. That the mold would be quick and reusable. That you could just pop it out without damaging the mold. So here, I didn't do that much research for injection molding. I've taken a few courses. I went to seminars in the past, and there's various techniques. So obviously here at the conference, and you have the experts, leaders of companies, chief technology, science officers, CEOs, financial officers, talking about the direction of technology. So here's a working mold injection. Does it show the heat? So you see the pressure, 683 psi. So I'm not sure if you can see this clearly. So try to see where's the mold. So that two pieces of metal right there are probably the mold, and it opened and the part is popped out. So it's hard to see the working parts, but somewhere in here is the material that's being melted and fed into the mold. And then at a certain time, the mold is released.
Morning, sir.
Yeah, I got just a local civil engineer.
Have any questions?
Educational.
Oh, nice.
Trying to get the basics of the molding process.
Very good.
Yep.
You need any brochures or anything? You need anything?
Yeah, I'll come back. I just want to finish my video, and I'll come back.
Thank you, sir.
Hey, God bless. Thanks a lot. So, what's the temperature here?
Temperature of the mold?
Yeah.
50 degrees.
It's 50 Celsius?
Yeah, 50 Celsius.
Will this be reconfigurable will this machine work for reconfigurable molds?
Absolutely, absolutely. You can put any mold in you like. That's what you mean.
And the materials also?
The materials are, yes, of course.
So
You can run whatever you want. Right now, that's a HTP. And,
how much do one of these machines run?
I think it's on here. No, it's not on there. You're looking probably at 100,000 for that machine, or less, probably 80, 85.
Oh, wow. So it's actually even, you say this is the material being fed in?
That's the material being
It
fed
comes in
right there.
pellet form?
Yeah, it's a pellet form. Yeah. I don't know why it stopped. Maybe they stopped it for a while. I don't know. Yeah.
Awesome. I appreciate it.
Do you need a brochure or you need
I'm going to come back. I'm just doing a quick video.
All right, that's fine.
Engineer, I can
That's fine.
conference. I'll come back to you.
Let me know if you have any questions, sir, okay?
Okay. Yeah, I appreciate it. God bless. Thank you. Okay, so that man was helpful. I was surprised this machine's only, he said, about $80,000. So there you can see pellet form of the material that would be melted. And this only requires to be heated to about 50 degrees Celsius to be melted, and it goes into the mold. And as you can see when the machine was operating, that it could pump out a part every few seconds. So if that was a HP, Hewlett Packard or something, but you know, if there's automotive or a widget or a gadget, you could pump out thousands of products a day. And you know, I said this is probably the most common manufacturing method, even for metals. So a lot of times metals are die cast and stamped, and you could use subtractive manufacturing for plastics and other materials. But this is the most common of all manufacturing methods, and a machine like this could make millions of parts, tens of millions of parts possibly. You know, if you had multiple, depending on, you know, the car or the needs, you could just have one machine or multiple machines that could make millions of parts. And you know, so the benefit of 3D printing is configurability. So you have to have the mold created, and you know, if the mold is some form of metal, alloy, iron, steel, titanium, I have to look into the material science, but you know, saying that the mold is some sort of metal that costs thousands, tens of thousands of dollars to make a given mold. So a bunch of interesting machines here. Really interesting stuff. I'm glad I came out. I am going to go around and collect reading material. So good conference. And so it's ironic that it's kind of a sign of the times, God forbid, you know, Rambo and the decline of America. This is much more important than 3D printing additive manufacturing. Like, there's a change in the industry in the direction of technology to additive manufacturing. But this is the mainstream manufacturing process. And to some extent, you could do this in your garage. Even like a die-cast machine, stamping CNC machine. You can have a CNC machine in your garage, but you know, people in Michigan used to have mom and pop engineering shops. So, like, obviously that machine costs $100,000. It's not cheap, but like opening up a restaurant, you could purchase as an entrepreneurial injection machine, make your mold, make a bid on a part. And you know, I mentioned I'm not going to go over too much, you know, the basic economic model of contract bidding, but obviously American capitalistic market systems are based on contract bidding, where the companies would put out, this is the part that they need, and then they would bid it out, usually giving the job to the lowest bidder. So if they need 10,000 plastic widgets, and they might get a few bids in for tens, hundreds of thousands of dollars, depending on the part. And if you put the bid in, you know, generally, they don't always just take the lowest bidder, but so you could have been a mom and pop's engineering shop in your garage, or you know, an industrial space, and put a bid out on a product, and you work at your capacity. Or there's major companies that have hundreds of these machines, international conglomerations, teaming up with the material suppliers or even the makers of the machines. So all of these people are here at the conference. I don't know, these days there's probably not that many mom and pops mold injection. But historically, if you were an inventor, you probably would have got a patent and outsourced and bid out your project to have your material made. Although it's conceivable you could come to one of these companies, purchase injection molding machine and make your own product. And the economics of that, it's tough to tell. Like $100,000 machine, you need an industrial space and power supply, parts, whether it be cheaper to make your own product. And even if you had toys, like if you were making board game or toys or chess pieces or something like that, and you don't actually need a machine to do plastic mold injection. So you could, like I mentioned in my article, I was a member of Tech Shop, and Tech Shop had molds. So I say you could make your own mold and melt the plastic manually and feed it in through like a funnel into a mold and do it one after the next. So tech shop people who were creating board games or something like that, if you're only going to create a few hundred molds, that you wouldn't need a fancy machine like this. You could technically do it by hand and just create your own mold, feed the plastic into it, and like that. But you'd like 3D printing. There's many companies that will take bids that you could contract to make a mold. So even if you had like a board game that had and actually 3D printers could print molds. So it's a material science. So say if the piece only has to be melted to like 50 degrees, and I don't know the exact material science thermodynamics of how much stronger the material the mold, but you could print out a plastic mold that is heat resistant to 100 degrees, and then use that as a mold for 50 degrees. And so so if you were making a board game or something that has 10 different plastic widget pieces and you want to make 100 of those, so you need 10 different molds for 100 pieces, you could 3D print the molds and do it in your house, or you could even hand make the molds, or milling, or various methods to have the molds making. So obviously this is Detroit, home of the automobile, and we have here mostly automated parts that would be made in high volume, tens, hundreds of thousands of them. If so that's why robotics manufacture in general, like I mentioned at some of these shows, is automotive or bust, because automotive makes up almost 50% of the global supply chain of manufacture. So if you have a device and you could get it into the automobile, that's the best economic path towards success. Because if you get your part into an automobile that sells hundreds of thousands of cars, you're going to be able to sell hundreds of thousands of your widget, and even one of these machines. So that's why these conferences are in Metro Detroit, and they're more focused on large suppliers. But the technology is interesting. So I'm just mentioning the fact that you could do your own plastic mold injection. You don't need one of these machines, but also $100,000, not a cheap sum of money, but you could even buy one of these industrial plastic mold injections. So like even if were making toys or a widget or dolls or any small manufacturing thing, even if you had an electrical device like the calculator or handheld device and you wanted to make the body to it, you could consider buying your own one of these machines and producing it yourself. It's probably relatively rare. And then there's, like this conference, so there's tricks of the trade. So, just like a 3D printer, they're not so simple. It's not like you could just buy a 3D printer and start printing out whatever you want. They're actually more complicated in technique, and a lot of times it doesn't work out like you thought it would. Even if you have your 3D CAD design and then you just try to print it out. So injection molding also, there's a lot of things that can go wrong, and so you have experts in the field, and that's why there's conferences like this, like the Royal Society of Science, the Ramble Along the Steel Conference, where experts get together and share tricks of the trade, promote their businesses, the global supply chain. So I think I'm going to sign off. Nice ramble. I said this is actually more important than 3D printing. 3D printing is more interesting, and there's a lot more new development. So this also, plastic mold injection has been around for, as I mentioned, it's the main form of engineering manufacture that's been around for thousands of years. So there's not a ton of new developments, although there's many new patents every year, material sciences and machines, but it's not necessarily like 3D printing where you're going to send people to the conference, or new people are coming trying to get ahead in life or learn about groundbreaking things, or it's even funded by the government, grants. That this is more like steel people in the engineering field that would need to be on the top of their game, and God forbid, I don't know too many like young people, engineers want to go into injection molding. It's like steel or something like that. It's the backbone of the manufacturing process. But so I'll leave it at that. God bless everybody. Take care, John. Thanks for tuning in. I'll hopefully get an HD copy later. So once I close this, just upload an HD copy. Hopefully, people can see some of the machines, some of the action here on the floor in Detroit. And I think next week I'm going to go to automation conference. That should be pretty cool also. This was pretty cool, seeing a lot of these bigger machines. You could actually see injection molding machines. Here's a smaller one. Said that you don't have to have like a huge, maybe even for tens of thousands of dollars, you can get a small injection molding machine. Next week, the automation conference should be really cool. There should be on display a lot of robotics. So God bless everybody. Take care. Signing out. Do video. Detroit.